Hey, this is Jason Molesky. In this example, we'll take a look at using Venn diagrams and two-way tables to find probabilities. Suppose in an apartment complex 40% of the residents read USA Today, only 25% read the New York Times, and 5% of the residents actually read both papers. Now suppose we select a resident at random and record which of the two papers the person reads. Now our problem is to make a two-way table that displays the sample space of this chance process. So to start with, we can lay out our two variables. They either read USA Today, or they read the New York Times, or they don't read one or the other, or both. So across our rows, we can put reads USA Today, either yes or no. In our column, we can say they read New York Times, either yes or no, and then we can actually use some totals as well. Next, let's start filling in our information. We know 40% of the residents read USA Today. So the total percent of residents who read USA Today is 0.40 or 40%. Likewise, only 25% read the New York Times. So we can put a 0.25 straight across from the yes under read New York Times. And we know that 5% read both papers. So we'll want to look for the intersection of yes, they read USA Today, and yes, they read New York Times, or right here, and we'll put 5% in that particular cell. Now, to fill in the rest of the table, we're going to have to use what we know about probabilities. Well, first of all, we know that the total for the entire table has to be 100% or 1. Next, we can just use some basic subtraction to fill in the missing cells. So, for example, to find the amount of people who do read USA Today but do not read New York Times, we can use the fact that 40% read USA Today, 5% read both, so 40 minus 0.05 is 0.35 or 35% who read USA Today but don't read the New York Times. Likewise, 25% read the New York Times. We know 5% read both, so that means 20% read the New York Times but do not read USA Today. Continuing around, we can use basic subtraction again to fill in the rest of the table. Next, we want to construct a Venn diagram to represent the outcomes of this chance process. So to start with, we'll consider our two events. Event A, they read USA Today. Event B, they read New York Times. We'll draw two large overlapping circles to represent the two events. We'll make sure they overlap because we do know that some individuals read both. We'll also want to draw a box around the circles to represent those individuals who don't read either newspaper. Again, we were told 5% of individuals read both papers, so where the two circles overlap, we'll put 5%. And from our table, we saw that meant that 35% read USA Today, but not the New York Times. Notice the total for the circle, 0.35 plus 0.05, equals the 40% of readers who read USA Today. We also knew that 25% read the New York Times. We've already accounted for 5% here, which means the remaining bit of the circle has to represent 20%. Finally, adding all the way across, we have 0.35 plus 0.05 plus 0.2, that gives us a total of 60% of the apartment residents falling within one of the two circles, at least one of the two circles, which means 40% fall outside. So 40% of the residents don't read either paper. Next, let's find the probability the person reads at least one of the two papers. Well, if they read at least one of the two papers, then he must read either USA Today or the New York Times or both. And as we saw, that's the same as the event A union B. We can find that by adding all three of those probabilities in the circles together and get 60% total. So there's a 60% chance he or she will read at least one of the two papers. Finally, find the probability the person doesn't read either paper. Well, as we saw, either you read at least one of the papers or you don't read either paper. So the probability they read neither paper is the probability of A complement intersected with B complement, or 40% total. It's the amount outside the two circles as we just saw. For some additional practice with using Venn diagrams and two-way tables, try exercise 55.